let me just say a bit what's going to happen. So I will a bit explain in the first part of that talk. I will be touch on some of the best practices and concepts. Okay, and that's really mainly food for thought, as we call it. Okay, and so basically it also means you do not have to agree with basically everything I say here. Okay, the content presented is really based on our experience. Okay, this is what we actually see in the field, what is happening in the industry, and this is also how our customers actually, or many of our customers actually proceed when they successfully implement their AppSec programs. And in the second part, we will actually show an example on actually how we can how this actually looks like or could look like in real life. Okay, so but before we get to that, a little intermezzo from my colleague Andreas. So he will greet you also, Andreas.
Well, also a very good, nice welcome to all of you. Glad to have you in this keynote with Jurgen. Allow me to introduce the team, Checkmarx. My name is Andreas Oswald. I'm the country manager here in Switzerland for Checkmarx. If you ever have the need to get a commercial offer or you need some consulting on how to best practice on AppSec, especially the automation part of it, then please don't hesitate. Don't be shy. Call me up. Send me an email. Even if it's just a love note, love notes are welcome also. We also, I don't have to introduce Jurgen, he already introduced himself. And David Schulze Gavrieli is our business developer. And on this call also is Rabia Khanfir, which is our technical assistant right here in Switzerland. And on the next slide, what I really would like to express, Jurgen, if you can, yes. Why are we actually doing this? Because a lot of times the programming community, the software developers, see security as something very malicious, probably even more malicious than having a bug or a security bug. But we're really here just to help you guys produce, the best code in the world, the safest code. That's what we're after, because we all know if we identify a security bug, down the road in pen testing, as opposed to even prior to a commit, we can save a lot of money. And you're saving a lot of money for the company you're working for, and you're making the world a safer place. That's why we're here. And so please do reach out to us if you want to have a one-to-one and you want to talk about maybe a project or what you're doing, how you can improve it on security terms, then don't be shy and call us. So I'll hand over to Jurgen, and thank you for being here this evening. It's lovely to have you here. Thanks.
Thank you very much, Andreas, for that nice for these nice words of greeting words. So we have a few little introduction before we then come to our live demo or how we work. Okay, so what is application security about? Why we're talking about that? And application security or code security or software security is really about protection, identification, and remediation. So what you're protecting are your organization's reputation, and more importantly is you're trying to fix security bugs. So maybe it's also a standards and regulatory compliance initiative like payment standards or healthcare standards. But really the goal is protecting what we call the PII, so the personally identifiable information. So that is, of course, your customer's PII. It could be your employees' PII or your company's trade secrets. The secret sauce, the reason why people actually buy your company's products. And that's really a very high-level representation of software security. And if this is treated as a separate entity or out-of-band entity, as it often is today, you're going to have issues with the very fluid software development practices that are current now in DevOps. And these DevOps practices, that's what, let's say, modern organizations at least are rolling out today. So we need to kind of find a way to reconcile these two worlds, and that's what this is about. So this, I think most people on this call probably have seen this kind of graphical representation in one place or another, and it's really a good representation of DevOps. Now, when we talk of DevOps or in other contexts, you often hear the phrase shift left. Now, question to the audience, or rhetorical question to the audience, where is left on that infinity loop that is actually representing DevOps? Where is right? Okay, there is, well, often, sometimes, or if there's someone is trying to answer, then often the answer would be code is the first step. But, well, not really, because today's software development process look really like a living, a breathing thing that is constantly evolving. It is a copy, an extension, a branch of an existing code base. So when you look at this infinity loop, there is not really a package or component of code that is only in one specific spot. Usually, there is something happening at all of these steps here all the time. And this is the kind of fluid nature of DevOps, especially if you are building hundreds of times a day. We have customers that have very aggressive timelines that that via microservice architecture are actually updating their production environments many times a day. Okay, so something is really happening at all of these phases, and that's why automation of security technologies is key to success. It's impossible. It is literally impossible for a manual process or any other type of what we call out-of-band process to keep up with the speed of DevOps. So from today's kind of landscape, where do we automate? Where do we actually integrate? And what you see on this slide, they're all technologies associated with different disciplines or actually phases of DevOps. They're not software security technologies. And this is the tooling and the components of the DevOps environment. You have your IDEs, you have your repositories, your code management systems, your platforms, your CI/CD plugins. Everything is there. There's one thing, however, that I would like to point out, and that is not so prominent on this slide, and this is this little Jira logo down here. It's black and white, but it should probably be red. And why do I mention that? This stands for the feedback. Okay, this stands for the best way to actually feed back issues to the person in charge. Okay, and it can be any type of bug tracking system, of course. So it's not specifically Jira, but that's really the way. Let's say, our philosophy is basically saying a bug is a bug is a bug. Okay, so any security finding should be fed back directly to this bug tracking system. There should be no difference. Okay, no difference between a functional bug. Okay, if you run your tests, if a unit test fails or a functional test fails, an issue is created and there is policies around it, and of course or every developer actually knows what to do. Okay, what to do next, and the same kind of policies should be applied to a DevSecOps process, to a security issue, which also means that the security issues, they are not something strange. In fact, what should be done, or what we kind of recommend, is to augment or extend the existing DevOps process by the security, but otherwise proceed exactly the same. So what we see today, of course, many times is this is kind of course, a very schematic representation. There's usually what we call some kind of single point of truth, where you have your build system, where you have your source code repository, where you have your deployments, where you have all kinds of different types of analysis, and everything is revolving around that. Okay, we will see this later in action. And just specifically also to say, well, where would you actually do this kind of checks? Okay, so today we'll actually focus on more specifically on static code analysis, but it could be any other type of analysis. I choose now, or we choose today, static code analysis for the reason because it is, let's say, something that can be applied to many different scenarios, and also in many different for many different programming languages, and it can be particularly in our case, it can be even applied in many different phases of the development. So you don't need necessarily to have, let's say, buildable code. So someone could simply create a piece of code, then let's say create a merge request. That merge request is maybe approved, and well, if you run your let's say SAST or any type of analysis just at the phase when you do your build, then that's a bit late. Okay, so another way to do is of course to maybe alleviate the life in the day of that lady, to basically be able to run these analysis maybe at a different stage. For instance, and we will show that, for instance, when she actually is trying to merge her code. But any other, let's say, point in this whole process could be taken as a kind of a spot or place where such an analysis could intervene. Okay, so now I think we will come to our demo. So I will just stop here. I will stop here and I will go to my browser. Okay. No, sorry. This one. Okay, so what I have here, and you might recognize that, is a GitLab. So I have a little repository with a piece of code in GitLab. Okay, and I'm working on this, and therefore I have issues. Okay, these issues are actually listed here. Okay, just to make it simple and easy to understand, of course, they're all security issues. So I don't build anything in here. I just want to understand what is my security stance in this. I see here that apparently there is an issue with an SQL injection. Okay, so I actually can click on that. I see here there's a description. Yeah, is there a question? Okay. Okay, so there is an SQL injection. So for to explain that for people that are not completely familiar what that actually means, it's basically a kind of a vulnerability where, let's say, a user input is taken, and that user input is flowing through the application and is ending in a database. Is used in a database query. And if, let's say, if there is no test that makes sure that this user input doesn't contain SQL statements, you might have an issue. Someone might, for instance, be able to steal data from that database. To make it very, let's say, high level, not go into too many details of that. Okay, there's a short description here, and also there is apparently 3 different issues on 3 different lines. You can actually go here and click on these on this line here and go to this code, so we can actually have a look at the code. So we see here line 41, and we also saw that 42 and 43 is also related to this issue, and we can see it here. Okay, so this is an issue. And what is the issue? The issue is actually we have here this user input. Okay, so this is basically something that is coming from a request, okay, from an HTTP request. Therefore, this is something that a user can manipulate. Now, an HTTP request, by the way, just to give you a bit of context, also is basically an API. Okay, so it could also be another API. It doesn't have to be an API for an HTTP request. It could be also a REST API or something similar. Anything that comes across an API, okay, is of course data that that you should not trust, or that any developer should not trust, and therefore make sure that it's either tested, okay, on contents, if it's indeed if that user data or user input is really what you actually expect, or if as an alternative, there's other ways. That's what we will do here. Basically implement the code in a way that even if it doesn't correspond to what you expect, it cannot do any damage. Okay, so the flow here is very short. You basically here, what happens here in this statement here is that these strings are concatenated, and if you do it in this way, basically concatenate these input strings, someone could really how to say that, create some malicious piece of input and maybe do some damage here. So how are we going to remediate that? So of course we can edit it here, okay, and I will just replace this insert statement that we saw here by by a prepared statement. Okay, so basically I will just do this in this way. Okay, I will insert here a new line, and I will take the code that I prepared here. So I will not type everything because that's a bit of too much for this presentation. I will just enter it here. Okay, I will put it in here, actually on this line, paste it here. Okay, and what this does basically is creating a prepared statement, and that's the proper way of actually creating SQL statement. And why? Because now it's not a string, because a concatenated string can be made into any type of statement. I could concatenate SQL statements and do anything I like, because when this then gets sent to the database, it could be executed and execute any type of query. It's in a way kind of there are similar types of vulnerabilities like code injection, or where basically code is executed that shouldn't be executed at all. So once I have done that, I basically could press here commit, and now I have forgotten something, because what I wanted to show is a bit of a slightly different data flow. So please bear with me. Actually, what you really should do is create. I would say leave here is create a new branch. Okay, so we'll create a new branch here. Okay, and we'll basically just say fix SQLi. Okay, create a branch. So to make this more proper, and do this again, basically. Okay, so we have our new branch. We'll go here and edit this file again. That's the same that we saw before. And I will not go through all these different explanations again. And it is in forum in the vulnerability folder. And we're back here. So quickly scroll down here. Okay, good. So we'll comment this out and do the copy paste again. Okay, and now we do the commit. And because I've set my pipeline, so I will say give here a comment, fix SQLi in forum.jsp. Okay, so I will actually commit this. And if everything worked well, okay, it should have started. Oh, no, I need to create a merge request, okay, which I should have done immediately. Okay, I will just do this, submit. Okay, and if I do the merge request, basically it creates, in the background, it will run an analysis, okay, and I can basically click here, merge when pipeline succeeds, but I want to actually stop for a second when this analysis is finished, okay, to see what actually we get as a result. You will get here, you could, one way to do that is actually wait, or you could even make the approval dependent on the results. Okay, there's different ways to manage that. In the true DevOps spirit, what you really want to do is probably not stop anything. It is really, you want to basically simply feedback any new issues that you have. But I just wanted to show that that you can actually always, at different ways, at different stages, you could intervene. You could stop things or have a look at it, or maybe if a developer pushes, this is a merge request, but you could also do the same thing on a push event. Okay, so that you say, okay, before even someone is pushing anything, you want to have a check. Okay, that is really kind of as early as you probably can do one. Okay, and so there's different ways to do that, but usually what we recommend is not stop anything, but let it run automatically and basically follow the issues and work on the issues that are basically put into the bug tracking system. Okay, so maybe we have I can see, are there any questions in the chat? I didn't look in the chat, so until this is finished here.
No, at the moment we don't have any questions in the chat.
Okay, so if there's any remarks or any specific questions for that, then please, we have a few seconds, and then we will continue.
It's always the same. It's the
no, it's because I have a free. I have to say I have a free account in let me just see here. I have a free account in GitLab, and that means I have the lowest priority. Okay, so this one, and sometimes let me just check something here. If it is running, okay, so that's good. So sometimes it goes into pending state, and I had it sometimes being stuck for an hour. So, okay, so I have here, where's my merge request? Here is it. Here it is. So, so I can see here in the merge request, I basically get the results. Okay, we can ignore that, but basically our issues regarding forum. So if I just to make this clear, okay, our issues that we had in forum.jsp are no longer there. So basically, this is something else. It's a different file. Okay, so there's no more issues. We actually have fixed all three issues, or the issues actually in what we're supposed to fix. Okay. And now I can basically go ahead and do the merge, do the merge. And if I do the merge, obviously, it will run again an analysis, and it will actually later on automatically close the issues here. Okay, so that's in a way a workflow, and you see I did everything here basically from GitLab, so that works, of course, with other similar systems like GitHub or like Azure DevOps, or even with the Atlassian, like Bitbucket and Jira. You could set up exactly the same thing, okay, in a completely integrated way. So that's basically what I said before. What is our philosophy regarding application security? It is about automation, okay, so automate everything. Nothing should be done manually, okay. It's basically issues should be created directly in the bug tracking system, and the bug tracking system here is actually is this one, okay. Okay, so for some reason it didn't close it. I don't know why. Okay, so it's not yet. Let me just see. Okay, it should have done that. Okay, so that's weird. Okay, so maybe I didn't fix it. Maybe the fix wasn't successful, but usually it closes that. The idea is really to have it in the. I didn't update it here. What is going on? Is it still running? It's still running. Sorry. For some reason, I thought it was finished. Okay. So, but we'll come back to that. What I wanted to show you here is something else also. What is nice. Okay. So you can actually, if you look here at these issues, you have a bit more information. Okay. So you have, of course, this description. You will have a link. Let's say you will have a link to the details and guidance, okay, which is basically going to the Mitra database, okay, that's this one. There is also a link directly to the underlying system, which I didn't show here on purpose, but which basically shows you also a recommended fix, okay. Okay, so it basically gives a description on what is an SQL injection, okay, what might happen, how does it happen, and so on. Okay, so there is this. Okay, and let's see if we have here if it's finished yet. So let me just check. Okay, so you see now that this has been closed. Okay, so the merge was done. The analysis was done again. It was recognized that this was actually being closed. Okay, and we have one bug fixed. Okay, so that's how you could actually work, or how you can actually work with a let's say SaaS solution. Okay, that you have it completely integrated in this case GitLab, and it tracks the issues directly in the issues. Now, sometimes, and I mentioned that in issues. Okay, so of course that's the other screen that I have here. There's also another screen often that is here. Okay, so this is the vulnerability report. Okay, so of course you could also create issues in here. However, this is a bit. This is exactly this type of out-of-band. This is the type of out-of-band process that we think is not the best approach. Okay, why? Because each time you actually someone actually has to go in here. Okay, have to click on that. Has to do a review. Okay, and then create an issue from that. Okay, so that's not automation. Automation is actually putting these issues directly into the bug tracking system. Now, I agree, and this is maybe a subject for another webinar or another meeting, is how to actually get to the point that we can be sure, or that anyone or every developer can actually be sure that whatever issue is created by such a system is actually something that they can rely on, That's beyond the scope of this meeting, okay? But that's very important too. But this is something that can be achieved, okay? But this is more, let's say, methodology, and that today I wanted to show, or we wanted to demonstrate a bit more, something more technical, something that is also, attracts more the development community. The other part is more maybe geared to more security-oriented people. Okay, so that's this part. Now, this is, of course, we saw Java code, and that is very nice. Now, you might want to try out this type of integration yourself, or you want to maybe play with this kind of static analysis yourself. And this is something that you can actually do. So some of the participants here, they might be cloud engineers. They have to deploy all kinds of stuff on different cloud platforms using different types of deployment systems. It could be a Terraform, it could be a Kubernetes, it could be Docker, any other one. Okay. And part of these deployments, often what you have is configuration files, is configurations, or what is generally known as infrastructure as code. And infrastructure as code is something is getting ever more important. But even if you're talking code, again, we're talking vulnerabilities, we're talking misconfigurations, we're talking hard-coded credentials and stuff like that. That it happens all the time. Okay, I see now this seems to be interesting. How do you shift left, security shift left in IAC? Well, I guess you start development in something. And again, the moment you have code, you can analyze it. The moment you have you can put it in a system like GitLab or GitHub or whatever you can analyze it. Okay. And that's actually all described here. So you have this. So first of all, this Kix is also a Checkmarx product, but it's actually free. So it's an open source. Let's say an open source project. Everything is managed in this case on GitHub. But here you have, for instance, the integration into GitLab, but you have that also for GitHub if you like that more or more familiar with it, or with Azure DevOps, or with Bitbucket pipelines. As said, usually we cover these four major systems. But actually, I think I know that the code here is sufficiently similar, so it also works probably for other similar continuous integration systems. Okay, so that's I would really recommend anyone that is interested in starting with Checkmarx to actually have a look at this. Okay. I hope this answered the question. As I said, shift left is not really what we really see. It's basically make sure that your code, that your infrastructure as code in this case is secure, and it doesn't matter whether it's right at the beginning or maybe in the middle or at the end, because of course, let's say the end of a project is the beginning of another one, okay? Or the end of a sprint is the beginning of the next sprint, and so on and so forth. And your code is reused, okay? So there is no beginning or an end most of the time. It is really something continuous, and you can start at any point. Does that answer your question? Or I hope it answered your question. Okay, good. So basically, this is kind of to conclude here what I wanted to show in this demo. We can basically summarize this again with one or two slides, and then I will give to Andreas for the final. So the idea really is here to basically automate the builds, or to basically automate the analysis. Okay, and you trigger on code commits, on pull requests, on any actual developer actions. And of course, the idea is to use these directly in systems like GitHub, Azure DevOps, or GitLab in this case, and so forth, and so on. Okay, so this is just basically the baseline of what the outcome of this. And very important, the ticketing system, the regular ticket system is used to close the loop in order to feed it back directly, these findings, and hopefully in real time. So, well, this is a bit shift your security policy left and right. In fact, have it everywhere. Have it always when you need, when you think you need it. Okay. We also didn't. We just talked about it more about the technical aspects today. Okay. So there is of course a bit of methodology. Okay. And usually there's also two worlds. Okay. So there's the development teams on one side, then you have the security people on the other side, and sometimes it's not easy that these two worlds, teams, departments, or there's different ways to express that, how they get along. And we often see these kind of, let's say, friction, and basically we try to address it and to resolve it in the way that we saw. Okay, so have security policies in place, but make it easy to consume for the development teams, so they can actually understand it and also agree with it. Of course, everything has to be integrated. That's something, by the way, that was discovered by the big shots in the industry, like Google, that they actually had an article about it. They found out, if this kind of analysis is not integrated into this kind of systems, then nobody will actually use it. Okay. And of course, develop. That's a bit maybe something for another meeting. Is develop security policies that actually fit that flow. So meaning, don't break builds. Okay. Often I hear in demos and things like that where can you break a build? And I usually say that's not something that we want to do, except something bad. Why? Because DevOps, and you know that, DevSecOps is that train that is the fast train that goes very fast. And like in a fast train, you don't want to hit the emergency brake unless it's really an emergency. Same here. Don't break builds. Have policies say there is a finding, there is an issue. Like for any other issues, react on it, but don't break anything. Okay. And by the way, we just talked about this, the source code that is developed by your different organizations, yet something else. Have an eye on your open source. Okay, open source components are very important. Make sure that these are also, that you also have a kind of a view on that. And with this, I think I pass on the microphone to Andreas.